Here we're exploring how we find the distance between any 2 points on the coordinate plane. And we call this the distance formula. So given any 2 arbitrary points, say x sub 1 and y sub 1, the distance between these 2 points is defined as follows. We say that our distance d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, I think it's very natural at this point to think, where did this equation come from? Well, in order to understand where this equation is coming from, we need to go ahead and recall Pythagoreans' theorem. So recall that Pythagoreans' theorem tells us that given any right triangle, that the sum of the squares of the 2 shorter sides is equal to the square of the longer side. Or in other words, a squared plus b squared is equal to c squared. So coming over now to our graph, we can set up a right triangle and apply Pythagoreans' theorem to attain the distance formula. So notice here, the base of our right triangle, length A, is in fact the change in our x values. We can see that A is defined as x sub 2 minus x sub 1. Very similarly, if we come now and think about the height of our right triangle, we can see that the height, b, is in fact the change in the y values. We can see that b is equal to the length, y sub 2, minus y sub 1. So we can now go ahead and apply Pythagorean's identity to our coordinate right triangle. So using Pythagorean's theorem, we have d squared, our hypotenuse, is equal to a squared plus b squared. We know that a is the change in the x values, x sub 2 minus x sub 1 squared, plus b is the change in the y values, y sub 2 minus y sub 1 squared. Now, the only thing here is that we need d, not d squared. So in order to attain d squared, in order to attain d, we need to take the square root of both sides of this equation. So taking the square root of both sides, we can cancel out the square on d. Just be careful to incorporate your brackets here for safety. So taking the square root, the square and the square cancel each other out, and we're left with d is equal to plus or minus the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And at this point, we need to go ahead and use our logic to come up with the correct final answer. We want to keep in mind that distance is a length, so it must be positive, no negative lengths. And voila, we have the distance formula. So this is the distance formula between any 2 arbitrary points on the coordinate plane.